Okay, welcome to this week's Megaport Live Tech Drop-In session. This one is on Megaport Internet. So I have done one on Megaport Internet previously that was a bit more of an overview and use cases and that kind of thing. This one is a little bit more of a deep dive on some of the technical details around IP addressing and routing and configuring the interfaces and that kind of thing based on some frequently asked questions that we get from the support team. So uh, maybe if you're not familiar with the product at all, it might be good to go and have a look at the previous video on the Megaport SA YouTube channel. But otherwise, I mean, you'll kind of pick it up along the way. As usual, feel free to throw any questions in the Q&A panel if you're on Zoom, or in the comments section if you're watching on LinkedIn, or later on if you're watching it on YouTube. Feel free to stick some questions and things in the comments section there. Otherwise, basically what we're going to have a look at today is how the service is delivered. So that's basically in the form of a VXC. So we'll just recover that quickly to sort of set some context on the rest. We'll have a look at the technical details of the service. So some of the features really, and what it can and can't do and things like that. We'll do a quick demo of creating an internet circuit. And then we'll talk about some options as far as the interface config, static routing, BGP, private and public ASNs, and advertising routes and that kind of thing. And we'll do a bit of a Q&A at the end. But yeah, as I said, feel free to drop questions in either the Zoom Q&A, LinkedIn, or YouTube, or wherever you happen to be watching. So basically, the internet service exists on a Megaport device. So we run our own hardware, our own internet points of presence in data centers all around the place. When you order an internet service, the internet service itself, the layer 3 interface, is created on one of those Megaport internet points of presence. But the way that it's delivered to you is via a VXC. So that VXC is the same as any other VXC for the most part on the Megaport network. It's a point-to-point layer 2 tunnel between some Megaport product on the left-hand side there, and then the other end being the Megaport internet point of presence. So I guess really the first thing, step one, is have that product, right? So it can be created from an MCR, a port, or an MBE, pretty much just like any other VXC. But step one would be to have that product. So have the MCR in place, have the port in place, have the MBE in place, whatever it is that you want this internet circuit to be delivered to. That'll exist in the portal. And then from that, you'll create this VXC. Same process as creating any other VXC, but you'll choose Megaport Internet as the destination. So that gives you kind of an overview of the components. So there's almost 3 separate parts, but 2 of them are sort of bundled together. There's the endpoint service, there's the VXC to the Megaport Internet point of presence, and there's the internet circuit itself, which is the layer 3 interface, the layer 3 component. To you in the portal, that layer 3 component is bundled in with the VXC, which we'll see in a second when we have a look at the demo. So basically, this gives you a bit of an image of what that ends up looking like. So these are just example IP addresses, and this is in the case where the internet service is being delivered to a Megaport port in order to be then physically plugged into some customer hardware. So if you were delivering this internet service to an MCR or an MVE, the process is exactly the same, the configuration is exactly the same. Really, the only difference is whether or not this internet connection wants to be delivered to a physical device of yours, so in the customer rack or on-prem if you've got some connectivity to a data center via some ports, or whether it's delivered to some kind of virtual appliance like an MCR or MVE. Everything else is exactly the same. So when that service is created, you get assigned a public /31, so a public subnet with just 2 addresses in it. The first address in that subnet is assigned to the Megaport internet end of the service, and the second one is configured on the customer end. So in this case, where it's delivered to a port, you've got a customer device physically plugged into that port. You create the internet connection in the portal. As soon as that's spun up, you'll be able to see what the IP address is that's been assigned to that service. And then you jump into your device, you configure the interface on your device with the second IP address in that subnet. And you'll be able to ping the other end, obviously. From here, you basically would be able to get internet out of that other end. The address is actually given out via DHCP. So if you choose, your device or MVE can be configured to request an IP via DHCP, and that'll work. It'll basically just broadcast that it wants an IP. The internet connection on our end will get that and respond back and essentially assign the IP address automatically. Typically, we'll assign a default route automatically as well. Sometimes that works. That's okay for some situations, but quite a lot of the time, probably most of the time, customers rather statically assign the interface IP, and that's fine as well. So either way, the IP is static, the IP is persistent, so it won't change. As long as this internet service exists, the IP will always be the same, so you can set it statically, or you can rely on DHCP if you prefer. It's up to you. So to give a bit of a technical overview of some of the features, as I said, when you create the circuit, you get a /31. So that's two IPs. One goes on the Megaport end, one goes on the customer end. So there's one single IP address that you can actually use. And that's the one that you assign onto the interface of your device that faces the internet connection. We also automatically assign a /64 of IPv6 addresses. So the service automatically supports IPv4 and IPv6. It's up to you whether you configure one or the other or both, but they're both there out of the box. So if you don't want to use IPv6, you don't have to configure it. Likewise, in theory, you could configure only IPv6 if you want, or both. It's up to you, but it is there, and you'll see it in the portal. And as I said, DHCP for IPv4 and route advertisements for IPv6. So IPv6 supports automatic configuration as well if you want to use it. Some things to keep in mind, we do network ingress filtering. So for the most part, you shouldn't really have to worry about that. If you do have to worry about it, you probably already know, and you're probably already used to dealing with it. Really all that means is we'll only accept traffic from the IP addresses that we expect to be on that link. So if you send us traffic from some other public IP that's not the one assigned to that internet connection, it'll be dropped. We block outbound traffic on port 25 as well by default. So that's really just to try and limit things, limit spam, basically, people either unintentionally or intentionally sending spam. It's generally kind of a best practice at this point. But if you do really need outbound port 25, we can allow that. You basically just reach out to support via the chat in the portal. Tell them what it is that you're doing. Maybe you're running a mail server or something, and they can allow that traffic, but otherwise it's blocked. But that's the only thing that is blocked. All other ports and traffic in both directions is allowed. The interface IPs, like I said, /31, /64. However, you can request additional IP addresses, and those additional IP addresses can be used either via static routes or via BGP, which we'll get into a bit later on. As far as BGP, we have both IPv6 and IPv4 neighbors set up. So even BGP itself, you can run over IPv4 or IPv6 or both, whichever you prefer. We can optionally set a password for that BGP session. Up to you. You know, when you request that BGP configuration, you can provide one or not. If you don't, then there won't be one set. We also filter routes there, right? So we sort of do some best practice stuff to try and limit some risks and chances for abuse and that kind of thing, where we'll only accept routes that are the ones that we expect to see. So that's usually, again, not really an issue that you have to worry about too much, other than when you set the connection up, when you request this configuration, you tell us what routes you plan to advertise, or you advertise the ones that you've bought from us. With BGP, the routes that we advertise to you, you have a couple of options there. You can choose to receive only a default route, which is probably, I'd say, the most common, or you can have customer routes or customers plus peers, or you can receive a full internet route table, which is probably the second most common, I would say, that I see. could probably equal roughly with customers and peers. Um, don't see a lot of customer only. Really, this is likely to be a situation where if you know that if you need full table, you probably already know. If you don't know, you probably will. I'd say most of the time only need default only, but the options, those options are all there. It's up to you essentially whether you want to receive just a single route or whether you want the whole internet route table. You might need that whole route table if you're doing things like having multiple different internet connections from multiple different providers and wanting to be able to see all the routes and choose the best ones and that kind of thing. If this is your only internet connection or you've just got a primary and secondary, something like that, um, default is usually okay in those scenarios. We do check RPKI. So this is relevant where you, as the customer, want to bring your own public IP addresses. So rather than Megaport provide you public IPs, if you own your own blocks that you've purchased through a regional internet registry like APNIC in Asia Pacific, and you own your own public ASN, you own your own public IPs, we do support you bring your own IP addresses, but we do check things like RPKI and route objects and things like that to make sure that everything is being advertised where it should be. We support both private and public ASNs. So again, if you do own your own IP addresses, probably you'll have your own public AS that you want to use. We support that. But if you don't own your own public IPs or ASN, you just want to be able to use BGP for dynamic routing and the other advantages, but you don't own your own IP addresses, we do still support using BGP with a private ASN with Megaport assigned addresses, or we can even do a private ASN with customer-owned IP addresses, provided all of the ownership stuff is in place. So jump into a quick demo and go through basically what it looks like to order the service. So just as an example, first off, we'll create a port. So Sydney, for example, let's maybe stick this in. So these are all the data centers where we have ports available. Let's put this in NextDC S1 just for the sake of the example. Give the port a name. Okay. So this is something that a lot of customers may already have in place. This is basically ordering the port to physically connect to Megaport, or you could be ordering an MCR or an MVE or whatever it happens to be. As I said at the start, like step one is have a place for this internet connection to actually be delivered to. So now that that's ordering, we'll click this add connection button here to add a connection onto this port. And this is the same process that we would use to connect to any of the cloud providers or connect to other data centers or anything else that you might want to connect to. But in this case, we'll choose Megaport Internet as the connection type. This will show us all the internet points of presence available and the latency to each of them, so we can choose which one we want to terminate to. This basically allows you to build out multiple connections to different points of presence for high availability purposes. We'll talk about that a little bit more later on when we get to the BGP section. So minimum speed for an internet service is 20 meg. And we'll say that we want this to be VLAN 100. I'll add VXC and order now. So that's basically how you order the internet service. So that's all there is to do in the portal. So basically what that will do is go and provision the interface, the layer 3 components and all the internet side of things, and is also provision that delivery via VXC to this physical port that we provisioned in NextDC earlier. So once this internet connection has been created, you can click on the connection, go into the details, and you'll be able to see the IP addresses that have been assigned. So that's probably the important takeaway here is it's really quick. You basically create it just like you would any other VXC. Once it's created, you'll be able to see the interfaces assigned. So you can see this one up here is the assigned interface. So this is the one that you would configure on your device, on your router or firewall's interface. This is the IP you'd configure there. And then this is the other end of that circuit. So this is the default gateway, the default route if you're using static routing. If you're using BGP, this is the BGP peer address, right? And same for IPv6. All right, so we'll quickly run through, well, we don't have a whole lot of time left, but we'll quickly run through some options here around the routing. So the simplest possible configuration is just to use static routing. This will happen pretty much automatically via DHCP, but if you do want to set static interface IPs, you can do that. And if you do that, then you have to create a manual static route on your device. Pretty much, you configure the interface IP address as the one that you got from the portal. You configure a static route, a default route that points to the gateway IP address that's also shown in the portal. So that's the other end of that that /31, as you can sort of see here. So those are the IPs that we saw in the portal a moment ago. And that's all you have to do. That'll work. That'll mean you've got an internet connection from this device. That may be all you need to do. If you need additional IP addresses, so out of the box, you get that one single IP that you can use. If you need additional IP addresses, there's a couple of ways to do that. The first way is, again, via static routing. If you're already using static routing and you don't need to do high availability, you don't have any redundant connections, failover or anything, you kind of just want a standard basic internet connection, then what we can do is route you an additional block of IPs. So we can't change the IP address of the interface itself. So your interface IP on your router or firewall will still be that original IP with that original /31, that single IP. But we can route you an additional block of IPs over that connection. So we can route you a /30 or 29, 28, something like that, over that point-to-point connection. And then on your device, you can use those additional 4 or 8 or 16 or however many IPs. Either you can continue to route them internally to another inside interface, or you can use it for NAT or whatever you might want to do. But I guess the important takeaway here is that the original internet interface IP doesn't change. It's still that /31, still that single IP. Additional IPs are routed to you as subnets on that interface. It doesn't replace the interface IP. So the next thing really would be BGP. So static routing works. There's customers that use it. If you just want an internet connection that sits there and does what it does, static routing might be fine. But as soon as you try to introduce more complex things, especially around failover and high availability, you really make things a lot easier if you use BGP. So if you have multiple internet connections, whether they're both from Megaport or not, whether one's from Megaport, one's from somebody else, doesn't really matter, or it doesn't matter how many, if you've got 2 or 3 or 10 or however many. BGP is sort of the standard way that you can have your devices know whether that connection is actually up and running and working, or whether it's down for some reason, and also which paths are available via each of those connections. So as you can imagine, if you've got 2 internet connections and you're trying to do failover between them, it's much, much easier if you can have those connections persistently telling you that they're either up or not, or available, or whatever the case may be. So it's much easier than much easier and much more effective than trying to configure failover and link monitoring and things like that on your own device and have it try to test the connections. You can just have the other end tell you. So in this case, we're using a private AS number. So this is useful when the customer doesn't have their own public IPs. They don't own their own public IP addresses, don't own their own public ASN. They just sort of want an internet connection provided entirely by Megaport. So in that case, you can choose which private AS number you want to use. You'd reach out to support. So currently this BGP configuration is not in the portal, right? So as you might have seen in the workflow earlier, there wasn't an option to configure BGP in the portal. That's hopefully coming sometime relatively soon. But at the moment, the way you request this is to log a support ticket via the chat in the portal. So you go through that that workflow, create the connection, you'll see the IPs there, configure your interface, make sure you can ping the other end, all that kind of stuff. But when you want BGP configured, or when you want additional subnets, basically just open a ticket with support, request what you need, and they'll get it sorted out. So in this case, we've got that original /31, same as we had before, with one IP on the customer side, one IP on the Megaport side. But now, rather than using static routes, we've got a BGP session configured between the customer device and the Megaport internet device. And those two IPs, the two ends of that /31, are the BGP peer addresses. So on the customer side, on your device, when you're configuring that, you've got that .18/31 address configured on your interface, and you'll add a BGP configuration. The specifics depend on the vendor that you're using, but you'll configure a BGP session where the peer IP, the peer address, is the .17 address, the other end. So that's because you're a peer from your device. The peer is the other end, is the Megaport internet end. And the remote AS number is the Megaport internet AS number, which is 49915. And then on your end, your local AS number will be a private one that you choose from that private range, and your local peer IP will be the .18 address. So that's basically how that works. That BGP peering is across those same two IPs, that same /31. Once that's in place, Megaport Internet will advertise to you whatever routes you've chosen. So let's just say for the demonstration, let's say this is a default route. So the Megaport internet side, that BGP here, will advertise to your device that it has a default route available, and your device will advertise to Megaport internet the IP ranges that you have bought from Megaport. Right, so if you've requested an additional /29, for example, from Megaport, and Megaport said, yep, cool, that additional /29 that you can use is that 203.0.113.64/29. On your device, you would advertise that IP address, that subnet, that prefix, you would advertise it to Megaport Internet to tell Megaport Internet that that's where it can reach that address. So basically, you have a default route in one direction and you have your local routes going in the other direction. This is really useful, especially when you start to talk about multiple connections, right? So we do offer multiple connections. We offer redundant connections in different points of presence in each city. You can have them delivered to different ports and different availability zones and all that kind of thing. And what this lets you do is have that same subnet, for example, the /29 that we've got here, and advertise it over two different internet connections on two different ports to two different points of presence. So you've got full resiliency, full high availability. We do also support a private ASN if you want to use your own public IPs. That's a little less common, but it is supported. Typically, when customers want to use their own private IP, their own public IP addresses, rather, they'll use a public ASN that they also own. So this configuration looks very, very similar. The difference here is that in this case, the customer owns their own public AS number and their own public IP ranges, their own provider independent IP address space, and they want to advertise that through Megaport Internet. So this is sort of sometimes called bring your own IP address or other things like that. Basically, this is where Megaport is not providing the IP address ranges, where the customer owns and is bringing their own IP ranges, and they want to advertise those ranges through Megaport Internet. The configuration looks pretty similar. So again, same /31. Again, the peer addresses are the customer device on one end and the Megaport Internet device on the other end. And over that BGP session, Megaport Internet will advertise to you a default route, and your device will advertise out to Megaport Internet all of your owned public IP addresses. So this one is, although the configuration is basically the same, it can sometimes be a little bit more challenging because there's some other things you have to consider when you want to bring your own IP addresses. So the first one is that you have to provide some information to Megaport to sort of prove that you do actually own these public IPs that you want to advertise. And you also have to have some records in place with the registrar, so APAC, for example, whoever your regional registrar is, to allow our systems to validate that you actually do own these IP addresses and that you have authorized us to advertise them. So we actually do have another video that digs pretty deep into RPKI and route objects and ROAs and things like that. And that's kind of in that space. So if you jump on the Megaport SA YouTube channel, there's another video there about RPKI. It sounds a lot more complicated than it is. It can be complicated, but if you need a complicated configuration, you probably already know. If you don't know, probably you just need a really, really simple configuration. And most of the time, you can do that by just logging into the portal of your provider, so APNIC, for example, and enabling these records. So you have to be a little bit careful. Just make sure that you don't break anything that's currently in place, but it's a whole lot easier than it sounds. And for most customers, they pretty much just need to turn it on. And you would do that in the web portal of whoever you've bought those IP addresses from. So that will be APNIC in Asia Pacific. All right. That's the end of the slides. Let me have a quick look if there's any questions here. Okay. What's the limit for BGP timers? Right, okay. So one of the questions that we have here is what's the minimum BGP timer? So basically the minimum timer that we'll support is 20 seconds. And so it's three lots of that, basically. Most of the time, 90 seconds, a 90-second hold timer is probably pretty standard for internet type services. You typically don't see internet services with really, really low timers because routes have to propagate across the whole internet and that takes time. And so if you have things flapping up and down really quickly, it can sometimes cause some issues. But that's a whole other giant topic and pros and cons and different ways you can address that. So basically the answer there is we support a hold timer of down to 20 seconds. That's the minimum that we'll support. It'll automatically negotiate above that. So anything above that is fine. Probably something like 90 seconds is common, but we do support down to 20 seconds. Let me have a look. Okay, password subnet requirements. Okay, yeah, cool. So there's another question about just the subnet, the BGP configuration, so subnets and things like that, and BGP passwords. So as I mentioned, you don't have to set a password for the BGP session. To be honest, it's not that common. Like it's relatively common for sessions to not have a password set because there's not really a way for you to access this thing anyway. So it's not like other situations where if you don't have a password, anyone can access it. Because you kind of need to be physically connected to this thing. There's less of a risk, but it's up to you. If you want to set a password, you can, and you provide that when you reach out to support to request the BGP configuration. If you don't provide one, we won't set one, so it's up to you. Otherwise, as far as the configuration, basically I would say just focus on that original subnet, focus on that /31 that you get, right? So we jump back to the portal here in details. If you just sort of focus on this setup, this will answer most of the questions, I think. So this one here, the assigned IPv4 address, I'm assuming we're just talking about v4 for the moment. The assigned IPv4 address, that's what you configure on your interface. So this is a /31, not a /30. So that's 255.255.255.254 in sort of Cisco format. And then this is the other end. And for the BGP setup, this is the peer IP. And so the remote ASN is that 499.1.5, which is in our docs. It's the same everywhere. And then the peer IP is this gateway address here. And then on your side, this is your IP address for your interface and also for your BGP session. Okay. Oh, okay. So we're at We're at 12:30, so we'll leave it there. But any other questions or comments or whatever, feel free to add them on the video on the YouTube channel. We'll try and keep an eye on that. Or feel free to reach out to your account team or whoever else you normally contact and go from there. Leave comments on LinkedIn, that kind of thing. And we'll use that to basically drive future sessions. Like this one here, being a follow-up to our previous internet video, is basically based on that kind of feedback. As I said, another video exists if you want to see more general overview stuff, use cases and things like that for the internet service. And another video is also up on the channel for RPKI to dive really deep into that route validation and authorization type services. But otherwise, yeah, that's it. So thanks for watching, and we'll see you next week.